Hello everyone. In this tutorial, I'm going to show how to layer roughness using Substrate inside of Unreal Engine. So let's get one thing straight before we start with the tutorial. Is this one thing that a lot of beginner artists get really wrong, and it's by design. And the thing is that when you have a roughness map and you use it on your texture in software like Blender, Marmoset, or here in Unreal Engine itself, they often tend to just plug the roughness map into the roughness slot, and then things start blurring wherever there is a reflection. But the logic that you need to get straight is that in real life, if you have looked at a chrome surface like the saucepan, or if you have a car with shiny carpet material, you'll soon realize that the reflection is not really getting blurry, but rather it is getting towards a diffuse region than the specular reflections that shiny surface tend to have generally. That's because with roughness layering, the surfaces get uh, less and less angular towards the light, thus making it more diffuse. So with that logic in mind, we can start with this tutorial and make photorealistic smudges and stains that just doesn't blur the surface but make it real and diffuse, like you see in the renders that I have made. So let's get started. So if I just open up the materials, and here I have the material instance, and then open up the master material, you'll see that it's surprisingly quite a bit simple material graph. And that's because with substrates, the material logic become really easier compared to those quote unquote Unreal Engine influencers online who tend to make the graph super complicated unnecessarily. And if you just ignore the draw calls, which is like the 2000 something instructions, and if we just move ahead with the material, we can simply just recreate it. So here I have the textured version, which is the marble tile that I'm using for the ground surface, and it is the same logic but with textures. So let's just get started with the simpler one. Now the base color goes to the substrate metalness to diffuse albedo, which is a new node in substrate which controls the metalness, the base color, and the specular. And we just have to plug the base color into a base color, and if you want metalness control, you can plug in a scalar parameter for the metalness as well, and that connects to F0 and diffuse albedo. Then there will be the roughness for the bottom layer, which is a simple scalar parameter with a value like this, or if you have a texture, you can just plug in the F directly into the roughness. And then there is the normal map that goes into flattened normal, and the scalar parameter that is inverted to control the normal map intensity, and then that goes to the normal map. There is a glint parameter that I was playing with, but I'm not really gonna use it in this tutorial, might be in some future tutorial maybe. And yeah, so that is the logic for the base layer for both the textured and the untextured versions. And for the top layer, which is our actual roughness layering, you'll see that first I have started with a MF tiling node, which is the node from the previously deprecated Megascans tiling logic that they have left in the 5.6, 5.7 version as well. And there is a roughness texture that I have downloaded from Ambient CG, or you can download from Megascans as well. And I have used the compression as mask because I don't want any rough RGB values interfering with her roughness logic. And then there is the color M node, which you might have seen previously if you have used Blender. So it works like levels in Photoshop. The black values are, the black bar controls the black values, and the white bar controls the white values. Simple as that. And then that color ramp output goes to two LERP nodes. One is this one. And this one basically goes to the transmittance color. So transmittance color for this node, substance transmittance to mean free path, makes the top layer basically transparent. And keep in mind that this blend mode is already set to opaque. So this mean free path and transmittance is faking the transparency of the material, so to make it sort of like a transparent layer covering the opaque layer that is below. So this lamp node goes to the transmittance color. So this, if I show you the lamp node, you'll see that there is this black and white values, and these black and white values control how much of the transmittance happening. There will be quite a bit high transmittance where there is large white values, and in the black regions like this or this, the transmittance will be lower. And then there is this another lerp node, and if I show you this one, it is a quite a bit high contrasty one, and this is controlled by these two scalar parameter, roughness low and roughness high, that controls how black or how white the roughness may be. That basically controls the roughness of the texture that we are using in the top layer. Now this same lerp node which we are using for the roughness is also going to the top thickness for the substrate vertical layer, which is laying the roughness material on top and our base material below. And this top thickness basically tells the material how to blend the top and bottom layers. So since it is a black and white texture, wherever there will be black, the lower material will be showed, and wherever there is white, the top material will be showed. And that way, although unlike previous legacy materials where roughness straight up blurs the reflections, this top thickness logic that we have built so far tells the material to just uh, make the reflections diffuse wherever the white values are appearing, and wherever there is black values, keep the reflection as it is, and derive the roughness logic wherever the white values are appearing from these two. Like somewhere there will be low roughness, somewhere there will be high roughness, like that. And if you have followed the tutorial properly so far, you will be able to create a material like this. And if I go to the material instances, you'll see that the values are like really simple to control the roughness of our material, both for the textured and the untextured material. And if I just play the sequencer, you'll see that the material is indeed working, and the reflections are not getting blurry, but they are getting diffuse to us wherever the white values are appearing, and wherever the black values are, the reflections are quite crispy, like this region or this region. So that is it for this tutorial. I hope you have learned something, and I hope you create more photorealistic renders with the help of this tutorial, and I'll see you in the next video.